From this lecture, we will start bipolar junction transistor. In short, it is called as BJT. BJT is the most important topic in this course. The inventors of BJT received Nobel Prize in Physics. Now you can guess how important this topic is. The transistor was invented in December 1947. The transistor was invented in December 1947 by the team of John Bardeen, Walter Brattain, and William Shockley at Bell Labs. USA. The head of the team was William Shockley, and later he invented junction version of the transistor. William Shockley invented junction version of transistor in 1951. They received Nobel Prize in 1956 for the invention of transistor. John Bardeen is the only physicist who received 2 times Nobel Prize in physics. The first one was in 1956 for the transistor. The second one was in 1972 for BCS theory. And this is the image of first transistor invented by the team of William Shockley, and the invention of transistor was revolutionary, and transistors replaced bulky vacuum tubes. This is the image of vacuum tube, and this is the image of modern day transistor. BJT is a 3-terminal doped semiconductor device, and it is used in amplification of weak signals and switching operations. BJT, the bipolar junction transistor, is a 3-terminal device, and it is used in amplification of weak signals. And it is also used in switching operations. So there is use of BJT in both analog and digital electronics. The next thing is physical structure of BJT. We have 2 types of BJT. The first type is known as NPN transistor, and the second type is known as PNP transistor. In case of NPN transistor, P-type semiconductor material is sandwiched between 2 N-type semiconductor materials. In case of PNP transistor, N-type semiconductor material is sandwiched between 2 P-type semiconductor materials. There are 3 regions in transistor. The largest region is called as collector region. The smallest region is called as base region. And this region here is called as emitter region. The terminal connected to the emitter region is called as emitter terminal, or simply emitter, and it is represented by capital E. The terminal connected to the base region is called as base terminal, or simply base, and it is represented by capital B, and this terminal is called as collector terminal, or simply collector, represented by capital C. As we have 3 regions, 2 junctions are formed. Let's say this junction is junction J1 and this junction is junction J2. Junction J1 is formed between emitter region and base region. Because of this, we call junction J1 emitter base junction. Junction J2 is formed between collector region and base region. Because of this, junction J2 is called collector base junction. If you remember the presentations on PN junction diode, we had 2 regions, PN, and because of this there was only 1 junction. Here we have 2 junctions, J1 and J2, because there are 3 regions. In case of PN junction diode, there was depletion layer across the junction. In the same way, we have depletion layer across junction J1 and depletion layer across junction J2. I will explain these things in great detail in the coming presentations. The same thing will happen with PNP transistor. This terminal is emitter terminal, this terminal is collector terminal, and this terminal is base terminal. Now I will compare the width of the 3 regions. collector is having the maximum width, then we have emitter, and base is having the minimum width. Now I will compare the doping. Emitter is having the maximum level of doping, then we have collector, and base is having the minimum doping. Size or width of collector is maximum because it has to collect the electrons and heat is produced in it. So if width is more, better heat dissipation will be there. The next thing is the cross-sectional view of the transistor. I will quickly draw the cross-sectional view of the transistor. This is the cross-sectional view. This region is emitter region and this terminal is emitter terminal. This region is base region and this terminal is base terminal, and the largest region is collector region and this terminal is collector terminal. This is the cross-section view of NPN transistor. You can also draw the cross-section view for PNP transistor. Everything will remain same. The only thing you have to do is to replace the two N-type materials with the P-type materials and this P-type material with the N-type material. The next thing is the symbol of transistor. We represent transistor by this circle in which this vertical line represents the base. This is the base terminal. This line represents the emitter and this line here represents the collector. This is emitter terminal, this is collector terminal, and we have to differentiate between NPN and PNP transistor. So I will copy this and paste it so that we have two similar symbols. This symbol is for NPN transistor and this symbol is for PNP transistor. Now to differentiate between the symbol of NPN transistor and symbol of PNP transistor, we have to mark the direction of current. This is base terminal, this is emitter terminal, this is collector terminal. In the same way, we have base terminal, emitter terminal and collector terminal. In case of NPN transistor, the electrons will move like this from N side to P side. So direction of current is from right to left, from P side to N side, or you can say from base to emitter. So we have direction of current like this from base to emitter in case of NPN transistor. On the other hand, in case of PNP transistor, the electron will move from N to P. So direction of current is from emitter to base. So the direction of current is opposite. In case of PNP transistor, it is from emitter to base. So this is how we differentiate between the symbols of NPN transistor and PNP transistor. I hope it is clear to you. We will use these symbols a lot in this course, so it's a good time to understand the meaning of this arrow in the transistor symbol. The next thing is the meaning of name, the meaning of bipolar junction transistor. But before that, there is one more thing that I want to explain. You can see we have two junctions and three regions. So it is like two PN junctions connected back to back. The transistor may be regarded as a combination of two diodes connected back to back. That's why knowledge of diode is very important to understand the transistors. Generally NPN transistor is used because mobility of electron is more than mobility of hole. Now we will move to the meaning of name. Why we call transistor as bipolar junction transistor. We have already seen the meaning of junction. We have two junctions in transistor, and now we have to understand meaning of bipolar. There are two types of charge carriers in transistors, and they are electrons and holes. Electrons are negatively charged and holes are positively charged. So we have two types of polarities. Because of this, we call transistors bipolar device. The name transistor is made of two words. The first word is transfer. And the second word is resistor. We have two junctions in transistor, J1 and J2. If junction J1 is forward biased, it will offer very low resistance. If junction J2 is reverse biased, it will offer high resistance. Weak signal is introduced to the low resistance and output is taken from the high resistance. Thus BJT transfers a signal from low to high resistance. So there is prefix trans, because BJT is transferring the signal from low to high resistance, and this prefix trans is taken from the word transfer. Transistor falls in the family of resistor, so we have Istor, I-S-T-O-R, Istor, in the name of the transistor, and we have taken it from the word resistor. So this is how we have this name transistor. I hope it is clear to you. The last topic in this lecture is regions of operation. Regions of operations. As we have two junctions, we have four possible ways of biasing the transistor. In case of diodes, only two types of biasing was there, forward biasing and reverse biasing, because of one junction. But in case of transistor, we have two junctions, and thus we have four possible ways to bias the transistor. I will quickly make the table. In the first column, we have the emitter junction, or you can say emitter base junction. In the second column, we have collector base junction, and in the third column, we have regions of operation. The first column is for junction J1, the emitter junction. The second column is for junction J2, the collector junction, and the third column is for region of operation. When junction J1 is forward biased and junction J2 is reverse biased, the region of operation is active. When operating point is in active region, or you can say the transistor is in active mode, the transistor operates as an amplifier. In this reason, the transistor operates as an amplifier. When junction J1 is forward biased and junction J2 is also forward biased, the transistor remains in saturation mode, and it corresponds to the logical on or closed switch. In the third case, junction J1 is reverse biased and junction J2 is also reverse biased. In this case, the transistor remains in cutoff region. And it corresponds to logical off or open circuit. And in the last case, junction J1 is reverse biased and junction J2 is forward biased, and in this case the transistor is inverted. And it is like we are switching emitter and collector. This mode of operation is rarely used. And in this mode, emitter and collector switch their roles. This is all for this lecture. If you have any doubt, you may ask in the comment section. In the next lecture, I will explain working of transistor.